Right, problem 11 says evaluate the integral of e to the 4x times the quantity e to the 2x plus 4. Because there are parentheses, I'm going to start this one by actually distributing the e to the 4x to both parts. So I'm going to still have the integral. It's now going to be e. If I have exponents and the bases are the same, we're going to add the exponents. So 4x plus 2x will be 6x. And then plus e to the 4x times 4 is going to be 4e to the 4x. All right, from here, since I do have a plus sign, I'm actually going to separate it into two separate integrals. So I'll have the integral of e to the 6x to dx plus the integral of 4e to the 4x dx. And now from here I can do some work. Actually, for each of them, if there is one e in the problem, we will let u be the exponent. So in this problem, I'm going to let u equal 6x. Du, the derivative of 6x would be 6 dx. I notice that I'm missing a 6 on the inside, so I will undo that by putting a 1/6 on the outside. So now this problem is a 1/6. Now this is going to be an e to the u du. And I know the integral of e to the u is just e to the u, so it's going to be 1/6 e to the u, and u is 6x. So that part is done. Okay, on this problem, this time again, if there's one e in the problem, we'll let u be the exponent. So I'm going to let u equal 4x, which means du will be 4 dx. Notice I already have the 4 and the dx there, so I'm actually all set up on this one, so I don't need to put anything on the outside. So this will now simply just be an e to the u du problem. I know the integral of e to the u is just e to the u, so it will be plus e to the u is just e to the u, this time is 4x, and then plus c, and that would be my answer. Number 12, we have the integral of the quantity 5 minus x times the quantity x minus 4 all over x squared, and this really looks like a big mess. We have lots of parentheses, we have a denominator. Since it looks so complicated, if we could try to simplify it a little bit, that would be our best bet. So I'm going to try to get rid of parentheses and then see if I can do something with that x squared. So the first thing that I'm going to do is actually FOIL the numerator. If I do that, I am going to have 5x minus 20 minus x squared plus 4x, and this is still going to be all over x squared. Okay, I'm just going to clean things up a little bit here. So I'm going to have negative x squared plus 9x minus 20. It's still all over x squared. Okay, the next thing that I am going to do, probably could take a couple of different approaches. I don't want to do a u substitution on this one because if I let u be the denominator, it's not going to solve any of my issues. So instead, what I'm going to do is bring the x squared up top. So now this is going to be the quantity negative x squared plus 9x minus 20 times x to the negative 2. And now I'm going to distribute that x to the negative 2 to all three parts. Okay, when I do that, I'm going to get negative. This 9x, or negative x to the second times x to the negative 2. If I add my exponents, it's going to be x to the 0, which will just be 1. Okay, and then plus 9. If I add my exponents, x to the 1 and x to the negative 2 will be x to the negative 1, and then minus 20 x to the negative 2. Okay, now since I have pluses and minuses, I can actually turn this into three separate integrals. So this is going to be negative 1 dx plus 9 x to the negative 1 dx minus the integral of 20 x to the negative 2 dx. All right. Okay, so now if I take the integral of my first part, the antiderivative of negative 1 is just going to be negative 1x. Okay, this next part is going to be a little bit trickier because if you try to add 1 to the power, which would be x to the 0, and then multiply by the reciprocal of the 0, which would be 1 over 0, so we cannot do this problem. So I'm going to rewrite this part as 9 over x dx, okay? And if you look at this, I have dx over x right here. And anytime I have a dx over x, that is going to be an ln, and the 9 is just going to hang out for the fun of it. So we're going to have 9 ln of x. So that part's done. And then minus, on this one right here, I can add 1 to the power. So I'm going to get 20x to the negative 1 times the reciprocal of that new power. So the reciprocal of negative 1 would still be negative 1. Okay, so cleaning this up, I'm going to have negative 1x plus 9 ln x plus 20 over x, because I'm going to move this back down to the denominator, not necessary, but I did, and then plus c. Okay, number 13, we've got the integral of 5x squared minus 3 over x to the 7 plus 5 times the fifth root of x cubed dx. Okay, once again, since I see minuses and pluses, I'm going ahead and separate it into 3 separate problems. Okay, now from here, I'm going to actually clean every part up before I even try to take the integral. Okay, this middle part, I'm going to go ahead and bring my x to the 7 up top, so it's going to be 3x to the negative 7. And then this third part, I'm going to rewrite this. Remember, roots grow on the ground, so the fifth is going to go on the bottom, so it's going to be 5x to the 3/5. Okay, now from here, we can, for each part, we can just simply use the power rule by adding 1 and multiplying by the reciprocal on the outside. So this one's going to be 5x to the third times 1/3. And then I'll clean that up. It's going to be 5/3 x to the third. This next one, I'm going to get 3x to the, if I add 1, I'm going to get -6, multiplied by the reciprocal of that. And this is going to be, if I clean that up, it's going to be plus 1 over 2x to the 6th. And then this part, I'll have 5x to the, if I add 1, it's really like adding 5/5. So this is going to be 8/5, and then we have to multiply it by 5/8. So that's going to, if I clean that up, it's going to be 25/8 x to the 8/5, and then plus c.